Test. Okay.
Yeah.
So,
We good?
yep. We good to start? Okay.
Are we standing too close? Yeah. The feedback.
Okay.
Okay.
So, our talk, SniffAir, an open source wireless framework. A bit about ourselves. So, Matthew Eidelb. I'm a senior security consultant at Optiv in their attack and pen team. Our responsibility is red teaming engagements, internal, external threats, and of course, wireless assessments. Stephen Derricott, senior security consultant at Optiv as well, same type of role. We're primarily responsible for a large bulk of doing the wireless and development and research. This is kind of where this talk and this framework kind of grew out of. So, wireless pen testing. You're on. You got connected. But why are we talking about this? So, wireless is becoming more and more commonplace with IoT devices, to the point of fridges being connected through some kind of wireless device, whether it be Bluetooth, Zigbee, Z-Wave. It's becoming so prevalent that the kind of quote that I love to always like to recite to people is, Ethernet is like running, wireless is like running Ethernet to your parking lot. People can connect to your network and not ever be in the building. Which, if you're a sysadmin, can be a very scary thought.
How many red teamers do we have in the audience? Yeah? How many blue teamers? Network admin? Yeah? Red teamers, we know when it comes to breaching a perimeter, it's usually not some Leo day or something that just hit the streets that we're getting in on. It's usually password guessing on a single factor authentication thing such as Outlook Web Application, OWA, or exposed single factor VPN is another common way that we get in, right? And that's just username and password. Doesn't require, any kind of special sauce or exploiting that. So a lot of people take protective measures on that, implementing multi-factor authentication. Nobody implements multi-factor authentication on a wireless network. However, it's that same single-factor authentication to your corporate network. Just something to consider there. Yeah. Yep. Oh, and all right. So, this is what we do. As wireless pen testers, these are the things that we're looking for when we come on site. So we're going to look at your access points, client devices connected to them, identify any rogues that are possibly on site, look at the traffic between clients and access points, see if there's any sensitive information that may be passed in the clear. We'll go over a little bit more detail of that later. There's also some active and passive techniques we can use to capture this stuff. Passive techniques, obviously, you're just walking through, just sniffing packets. Active, you're actively querying, you're sending things to the access point to get data back. And then we develop attack vectors based on this information that we've seen. Now, this talk, our tool that we've developed here, SniffAir, this isn't just for red teamers. This isn't just for attacking. We want to make it known that blue teams can use this information as well. They can utilize this tool to help defend their networks. I just list all these things that I'm looking for when I come on site. Blue teamers, you should know this about your own network. You should know your access points. You should know your SSIDs. You should know what kind of encryption and authentication they use. I can't tell you how many times I've showed up on site to start doing a wireless assessment and I'm like, oh, which SSID is yours? I don't know, right? Or do you guys use username and password based or is it certificate auth? I don't know. How do you not know that? You use that. These are things you should know about your own network. Right? And so this is output here from Aerodump, just shows you some of the things that we just talked about, right? So we have the BSSID. It's just easier to say, we'll go ahead and level set here. BSSID, we're going to refer to that as the MAC address. That's the MAC address of your device. Whereas the ESSID, we'll just call that the SSID. That's what everyone knows. That's the human readable name of your access point, right? So here's a lot of information that you can determine. The power there determines, distance to and from the access point based on that. The amount of beacon frames, data frames, etc., the channel that it's broadcasting on, encryption, and authentication as well. Yeah, we can go to the next one. Right, okay, so now we're going to start getting into this, some of the technical things, into the actual frames that are broadcast from the wireless network. So, beacon frames. Beacon frames is just the access point saying, hey, my name is whatever, right? You pull out your phone, you enable Wi-Fi, you see a bunch of wireless access points pop up. Your phone is interpreting those names from beacon frames that are just being broadcast constantly. A lot of information that can come from beacon frames. The MAC address, obviously, that it's coming from. The SSID, the name, clearly. Then capabilities, what channel it's broadcasting on, the encryption, and the authentication in use. So now we'll talk a little bit about probes. Now there's two kinds of probes, a probe request and a probe response. So probe request is going to come from your phone. So you go to your friend's house, you go to Bob's house, you use Bob's Wi-Fi. Whenever you leave Bob's house, if Wi-Fi is still enabled on your phone is constantly sending out probe requests saying, hey, where's Bob's Wi-Fi? Where's Bob's Wi-Fi? I want to connect to Bob's Wi-Fi. But since Bob's Wi-Fi isn't broadcasting any beacon frames, you obviously don't connect to that network. Now, a probe response is obviously a response from an access point. So your phone says, hey, where's Bob's Wi-Fi? A probe response would be, hey, I'm Bob's Wi-Fi. Let's talk. Let's communicate. And there's a lot of information as well in the probe response. The same information that can be found in a beacon frame can also be found in a probe response. And another little thing that people typically don't consider, with hidden SSIDs, you try to hide your SSID, right? So it's not being broadcast everywhere. However, your phone or whatever wireless device you have that's connected to that hidden SSID is actually passing that SSID in the traffic. So it can be recovered passively. Just being in the right place at the right time, you can uncover that hidden SSID. And SniffAir will show you how to do that as well. All right. So now we're going to talk about the extensible authentication protocol. And this is typically
known as EAP.
Yeah, EAP. And this is going to be authentication, right? So a client device is authenticating. When we're talking EAP over LAN, those types of packets, when you're looking in Wireshark, that's going to be your four-way handshake. For those of you not familiar with a four-way handshake, when it comes to recovering a pre-shared key for a wireless network, one of the things we do as an attacker, we will passively listen. And when you intercept the connection, say I pull up my phone, I want to connect to a pre-shared key network, I put in, the password, my leap password. As soon as I hit connect, there's a transaction that occurs between the client device and the access point. And that pre-shared key is encrypted in there. So by capturing that four-way handshake between them, you actually have the encrypted pre-shared key in there. So we can we capture that four-way handshake and then recover the pre-shared key using GPU crackers or things along those lines. When it comes to just regular EAP, that's WPA Enterprise authentication. Now, the way that this works, EAP first establishes, so there's an initial server certificate exchange, and it's not authentication, right? I make the comparison when you go to Google. You type in Google, you don't really see it, but your browser is presented with a server certificate that you accept before that HTTPS, that SSL connection is formed, right? You didn't have to authenticate. It's just a server certificate to let you know who that distant server is. Same thing happens with WPA Enterprise. When your client device connects to a WPA Enterprise network, the distant server, the radius server, your whatever you're using for 802.1x authentication is going to present a server certificate that must be accepted first to establish an initial EAP tunnel. Within that EAP tunnel, there's other authentication that takes place, such as EAP-PEEP, EAP-TLS, EAP-TTLS, etc. And next slide. All right. So, on kind of backtracking a little bit, that it's important to be familiar with those types of packets, not just from a red teaming side, not just from attacking, but from a blue team side as well. You need to know what kind of WPA Enterprise authentication is in use. If you're using username and password-based authentication as opposed to a certificate-based authentication, like a public key, right? There's things that we can do to intercept that information passively. So it's important for blue teamers to be aware of that as well. Now here we're listing a few other attacks. These are common attacks that we do. We mentioned a lot of passive monitoring. We can uncover a lot just from passive monitoring and Matt will show a lot of that later. Client-to-client attacks, man-in-the-middle type attacks, right? It's good to be familiar with how those are done. Brute force attacks, we'll go into that as well. Aside from brute forcing, say, a pre-shared key, you can actually, password guess against a wireless network, which is a widely underlooked attack vector. And then another common attack vector is misconfigurations. Client devices that just trust unknown certificates. When I was talking about that initial certificate exchange that happens, if your client device just trusts any old certificate, when I stand up my evil twin with my own Radius server producing my own BS, server certificate, and your device accepts that, I can now intercept your credentials, and I can do a lot of other sneaky stuff as well. Go to the next one. All right. Yeah. All right. So, again, things to be aware of. I'm not going to hit on this too much, but I will say be aware of what type of 802.1x authentication is in use. Just by looking at these, EAP-PEEP and EAP-TTLS are username and password based. You should know that. You should know if that's what you're using, then that's your authentication scheme. Red teamers, when you're looking at wireless traffic and you see EAP-PEEP, EAP-TTLS, you know, okay, that's username and password based. If you see EAP-TLS, that is certificate-based authentication, which is really hard to bypass, really hard to attack. So you should be using EAP-TLS. If you're using WPA Enterprise, you should know what you're using, and it should be EAP-TLS. We'll go to the next one.
Well, one last thing about EAP Fast. So a lot of vendors in the past year have started thinking that it's very clever to do what's called EAP chaining, where they take multiple forms. So they might take, EAP MD5 or EAP Fast and put something else like, say, auto run Cisco VPN configuration, automatically log in using domain credentials as a secondary tunnel. But with it not being properly configured and stuff, it's a simple man-in-the-middle attack, but a lot of companies are opting to do this because they hear there's an additional layer of security. So it's really important to understand, and it kind of plays into what Stephen just mentioned about configuration, to know your configuration, but also know the flaws and how to kind of correct them.
Right, and real quick, when I was talking about the EAP authentication and the EAP tunnel, how that happens, I mentioned the initial EAP tunnel is established, and then inside is that inner authentication. PEEP, TLS, TTLS, that's your inner authentication inside that EAP tunnel. When we're doing man-in-the-middle or evil twin attacks against these wireless networks, what we do, a lot of people are familiar with SSL downgrade attacks, right? That's all over everywhere. Every pen test ever has an SSL finding, right? Poodle and all that stuff. We can do a similar thing where we downgrade the connection to an EAP GTC standard, which the credentials then get passed in clear text. So we don't get a hash. We don't have to crack it. We literally have domain credentials in clear text just from downgrading that connection. That is supported just with backwards compatibility. Each GTC was made by Cisco for phones, right? For that backwards compatibility with future systems. So it's pretty much always there. Yeah.
So what is SniffAir? Simply, it's an open source framework we developed that its main purpose and design was to take large amounts of data and provide you a way to store and manage and profile and go through it in an effective way. How many people here have actually looked through a Wireshark packet dump? How easy was it to find what you were looking for in the first 2 seconds? Exactly. So the whole point of one of the reasons why we developed this was there had to be an easier way, especially the nature of wireless engagement stuff. You really need to find this information in a clear way fast. As well, you need to present it to a client in a way that, maybe they're not so familiar with Wireshark that they can understand the breakdown of a packet. So that was one of the big pushes, was some way to display this information in a way that attackers and defenders can understand and kind of correlate between them. The other aspect is incorporating attacks and different ways to test, validate, and perform these type of network or client-based attacks. I mentioned a little bit before about aggregating data. So you can either feed it a PCAP file or a series of PCAP files, or you can actually use it much like you would do with a Kismet or AeroDump by doing a live sniff option. And that one will just, as you're collecting data, as you see it come across your screen, like, if you've ever done one of these, you'll see packets, SSID names, all this information. As that information is coming across your screen, it's being parsed and loaded into the database, which is the back end. That back end process uses a very finite engine that basically breaks down determining what type of packet it is. Is it a beacon? Is it a probe request? Is it a probe response? Is it a enterprise EAP packet? And depending on which packet it is, it actually will pull that information out and store it as a row in a table. And once this collection is done, it actually then recursively goes through to clean up any duplicates. As Stephen mentioned a little while ago, that probe requests are constantly being sent out. And so you can get numerous of the same one. So this one actually filters it down so that way you get less data to have to pilfer through. So we've kind of been talking a lot about things. So let's go show you how it works. Oh, this thing is fun. Okay, so. So, first table, we're going to show you. Oh, this thing is hard.
And before you can go ahead and keep typing. But so this is useful not only as attackers, but for blue teamers as well. Like Matt mentioned, you can import a PCAP that you have previously captured. Say you walk through your office and just want to load it in, or you can actively capture with SniffAir. So this is something that blue teamers could be looking at as well to get an inventory of your own assets.
Yes. So you can see this table's in a demo mode because you can get large amounts, but I didn't want it to roll off the screen. But you can see a list of all the access points we were able to gather, who made them. And this is all based off of Wireshark's fingerprinting engine. The lowest power. So power is one of those things that the lower the number, the closer you are. So you always want a lower number when you're looking at which one to target. The type of authentication scheme, the encryption being used, and even what channel it's sitting on. So this table right here just shows all the gathered probe requests. So as Stephen mentioned earlier, these are actively like devices, laptops, cell phones. They're sending out these requests looking for these networks. So we can see, what type of devices, what type of Mac card, or who created it.
Yeah, so looking at that data, if we were to collect in this room and look at the probe requests, we'd see, people's home Wi-Fi, their jobs probably, things like that. There's a lot of information that you can gather just from looking at those probe requests.
And then probe response table. So you can see who responded, the actual access points, MAC address of that responded, who made it, what channel are they sitting on, and what specific client did they send the packet to. So this stuff is all available. You just can passively sniff it, and this is being pulled down. So here's an interesting aspect. So this is the EAP table. We were mentioning about enterprise packets and authentication. So EAP was developed, I think it was in the late 90s, early 2000, and it has a systemic flaw that can't be fixed. As we all know, there's a heartbeat before the handshake begins with most, TCP handshakes. With EAP, however, they thought it would be creative, and a way to save time is that the username that would be sent would be the heartbeat. So if nothing came back, it would just fail. But part of the problem is that they couldn't create a heartbeat that was encrypted. So systemically, usernames are being passed around unencrypted. So you can easily sniff and gather a series of usernames. And we'll talk about this with one of our modules about brute forcing, but you can essentially be sitting in a coffee shop or nearby a client and see all their usernames and just start gathering them as they walk into the building.
Right, and I mentioned earlier, one of the number one ways of breaching a perimeter is password guessing, right? We typically go to LinkedIn, pull some names, try to find an email, format it, and then just guess a bunch of stuff like that. However, when you're doing that, you're guessing, their username format. You don't know how their domain usernames they might just be a bunch of random numbers. You don't even know exactly what they could be. So with this, you are capturing legitimate domain usernames just passively, just by being next to the network, right?
So one of the other features we incorporated is instead of having to look through the tables, you can actually query for a specific object. So with this command, you can just do show and you can list anything. You want SSIDs, you want MAC addresses, channels, And this will look through every single table, not just like the probe response or access point table. It looks through every single one of them and correlates to see what you're seeing. Because maybe you didn't see an access point for one of these networks, but you see a lot of probe requests. And that's an interesting attack avenue where you can get them to kind of connect, set up a malicious access points claiming to be that one, and it'll automatically connect to you. So as you can see, there's a lot of information. So one of the features we've incorporated into is an ability to in-scope the ones you want to focus on. And what this does is it takes, it goes through every single table and creates its own separate tables for just these SSID names. So that way you don't have to see a lot of erroneous data that you don't care about. Like maybe if you're in a shared tenant building, or if you're downtown, you're getting tons of wireless connections. You just want to focus in on the ones that you care about. So you can do this using the in-scope command.
Right, and this is great for red teamers as well, because when we want that tactical precision in our attacks and the things that we're analyzing, we don't want to mess with anything outside the building, things that are out of scope, right? Same thing for blue teams. This is a great way for you to collect, and you should know your SSIDs, right? So you could also filter out erroneous things of nearby businesses as well, so that you have a better picture of your own environment.
So once you've done that, you can actually get a nice, clear display of just an overview of what those in scope or all that information associated with it using this SSID information module. So what this does is it actually will list, as you can see right down here, all the BSSIDs associated with that SSID name, the vendors, the channel, and the type of encryption. So you can see right here there's some weird things with the Star Labs. You can see, why is there two sets of encryptions? Why are there two vendors? So that right there kind of gives you an idea of how you can drill down. If you're looking for rogues or something suspicious or something malicious or out of the ordinary, you can kind of get a good sense using these commands. So Stephen mentioned a while ago about hidden. So one of the easiest things, there's kind of two ways to discover hidden networks. As Stephen mentioned, they are constantly sending out packets looking to see if one of those hidden networks is in the area, and then if they are, they just respond. So there's a way of passively enumerating through based on looking at the probe requests, the access points, and the probe responses to deduce which ones. So there's a module we came up with called show hidden. And what this does is it looks at every single probe request that had a name that did not show up in the access point table. And it looks to see if any of those clients received a probe response from an AP that was previously registered in the AP table as being hidden. And if it does, we can then figure out what the actual SSID name is. And what happens then is it actually will update the AP table with all those actual SSID names. As well, it does create its own table, so that way you can go and look back and see specifically which ones down the road, say maybe for reporting or an engagement with a client, or you need to go back and check something, you can see specifically which ones were discovered as hidden.
Right, and keep in mind this is completely passive. We've already captured these packets. We're doing this after the fact. We don't have to go back. We don't have to actively send packets to the access point to get this information. This is all just passively collected that we're doing offline on our own computer, not having to do anything.
So here's that table. So you can actually pull this up. I find it there's a lot of value. I've had clients come and say, hey, you were able to discover hidden ones. I want to know which ones, because obviously I want to go fix it. So you can literally just take this and export it out, and they have a list of the MAC addresses and the names associated with it that they can go and run with. So there's a lot of valuable things that are just passively thrown out that this framework allows you to analyze and kind of deduce. There's also a function, say, for instance, we've come up with many different commands and stuff, but there is, because it's SQL, there's still the core function of doing your own queries and statements. So you can do that by using the query command. I'll show you an example right here. It just follows the normal SQL syntax. Sorry for the delay. I can't see it up here. I have to look over here and strain my neck. That looks right. So you can see we can do your own SQL commands if you needed to pull out something that maybe wasn't a command that's pre-built, something like that. It gives you a lot of functionality to control depending on what you need to do for. Now there are some other commands that allows you to profile and kind of to do some of this suspicious information. We actually developed this module called Suspicious AP. And what this does is it looks at all your in-scope networks and looks for anything anomalous. Like we showed you with that SSID info, there was 2 different types of encryption. Well, that's usually like a red flag because why? So with this module, it goes through some of the basic characteristics for malicious threat actors would do or maybe miss up, as well as rogue access points in your environment. And I'll show you right now. So what it's doing right now is it looks at 3 different things. First off, it looks at the channel and say, hey, well, all your APs are sitting on the most common channels, except for these. These are on ones that have no business. These are out of the ordinary. The other thing that it looks at is the vendor. It says, okay, well, you have a lot of, say, Cisco stuff, but all of a sudden we're seeing TP-Link. That's kind of odd. And then finally, the most obvious thing is the difference in encryption. So you can kind of get an idea of what's running, what's not, that's misconfigured, or maybe malicious that is in your area or that was captured in your collection. As well as no tool would be without some type of way to do some rogue AP hunting. So there's a module that we came up with called Rogue AP Hunter. So what this does is you can specify different power levels and different types of encryption, and it will show you based on what's inside the database what would come up. So if you were to say, I want to see everything that's below power minus 60, you can see, okay, so here are all the ones that are below minus 60, and then these are ones that are listed as open, but you can then change that encryption if you want to. So it can kind of give you an idea of what's inside your network without having to go trace it around and look around. So it kind of gives you an idea of what to expect. Okay.
Yeah. All right. Password guessing. We mentioned this earlier, touched on a little bit. Really, really underrated attack surface. We mentioned earlier just password guessing domain username is a great way to get onto a network. Also, sometimes it's your only attack vector. Say you discover a rogue in your network and it's a pre-shared key network, but there's no clients connected to it. Without a client connected to it, you can't recover a pre-shared key, and you can't really gain access to the device that way. But however, what if you just threw passwords at it, right? How many people think of that? It's really slow. That's why no one does it. But it's definitely something that we've added in here just as another attack vector that could be utilized in those scenarios where that's the only option you have. And now we have a video.
So here's a demonstration of actually the module being used to do password guessing. So the module is called AutoEAP. As we mentioned, it's like an automated EAP password guessing. So in this demo, you can see that we have a series of access points. And we look to see, okay, we see which ones are basically enterprise. And then we look at the EAP table and we can see what usernames are associated and where are they connected to. So we can see that they're all connected to the ESSID of Honeypot. Okay, so now we know what network we're going to try to brute force against. So much like Metasploit and a lot of other frameworks, a lot of these attack modules have preconditioned things that need to be set up. So the interface, the network name, the type of encryption, the type of key management in this case, and then of course like your username list. You don't have to specify a username list, but instead what you can do is just, if you leave it blank, it will actually just look at the database and go off of what was collected passively. And then finally, obviously, the password you want to guess. So, we all know that weak passwords are a common thing that's still plague in 2018, where season and year are a very common attack exploit. So we're going to use summer 2017. because in this case, this company doesn't update every year. So on the right-hand side, you can see this is the log, basically the debug of an actual Radius server. So you can see the requests and how they come in, and how they're being processed. So based on the communication between the two, this module actually will read the responses to determine if the password is valid or not. And one of the reasons why it goes through this and it's a bit slower is that there are some issues with if you don't get a response. Wireless is by default nature is to try again, reconnect, and what you're doing is just generating more auths against the same username, which if you ever had an issue like that or some kind of misconfiguration with a password guess, you can lock out accounts and a client can be really, really unhappy. So there's built-in features to prevent that from happening. So you can see right here which ones were successful or not, and every time you have something like successful, I capture anything, it goes into a loot table. So now this one is what we call auto PSK. It's the same type of technique of brute forcing, but instead of it against an enterprise-based network, it's solely against pre-shared key networks. So how this is...
Oh, thought we begin.
No, I just restarted the video. That was...
Oh.
There we go. Okay. So same sort of kind of philosophy and technique where we're going to be taking a word list and trying to figure out what is the common pre-shared key value. So in this case, we only have this honeypot network. So we're going to set up the same way we were talking about before. You just have to set up the interface, the SSID, and the list of like the file with all the passwords you want to try.
Right. As a red teamer, right, you're not going to run RockU against this, right? You don't want to run 3 million words because, as you're going to see in a second, this is really slow. So what you would target your word list. Say if you're a red teamer, you're on an assessment, company name, something, company name 1, 2, something like that. If you're a blue teamer and this is a rogue device that you found on your network, and there's no clients, right? So you can't get a pre-shared key, and you need a password guess. You could see from the vendor that it was a TP link, and there's a lot of vendors out there that have like pre-issued, pre-shared keys, right? And there's a lot of open source information out there. So you can say, oh, this is a TP link. What are the typical kind of default passwords that come with these devices? And you could base your word list around that for a more targeted approach instead of just blasting a bunch of words, right? I mean, you can see how slow this is going. It's gonna take a while.
So this is effective, but like Stephen just mentioned, it is slow because what it is actually doing is making a legit handshake connection. So each time that you try to connect, it's actually it sets up the SNOS, the NNOS, all the values you need for a proper handshake. So that's why it really comes down to doing some pre-reconnaissance to figure out maybe the company's policy is this, maybe through some surveillance or some looking around that they just use, default Aruba or something like that. So you can kind of get an idea of what to expect. Yes, in this case, this company is really secure. So, evil twin attacks. So we mentioned a little bit about this before, but the act of an evil twin it's in its name. We're setting up a twin of a legitimate access point to perform evil things. It's very effective against enterprise-based networks, where you can capture handshakes containing domain credentials that are either hashed or in plain text. This is great also for doing captive portals or maybe they have a guest portal where there's a self-signing, maybe it's a login using domain credentials, it's just a little page. Setting up a legitimate access point masquerading with like a web console, a web application, and just reading the logs as everyone tries to log in.
Yeah, so how many blue teamers in here send out spear phishes, right? You got to test your employees for spear phishing. People do that. This could also be another way to test your employees for security awareness by standing up that evil twin and seeing if you actually can get people to log into a bogus, phishing website or a bogus captive portal, et cetera, and so forth. So this isn't just things for attackers. I keep stressing this. Blue teamers can use this tool as well for numerous things.
So with Evil Twin, there's a few other things that need to sometimes happen. So about 3 years ago, Apple caught on to this really well and decided to start doing some cert pinning with regards to Evil Twin attacks, that they would not allow their Apple devices to connect without a proper cert. And so the way around that is if you just can connect to any network, you can see the cert information, all that generic stuff like the city, the common name, and all that stuff. And you can use Linux-based tools to generate your own cert. So if you check off the basic things like common name, all these type of modules that are listed right here, it kind of bypasses that Apple security. So these attacks can still have success against iOS and Apple devices. So once these are all set up, you can then generate the cert, and what it will do is it will pin it to all your legitimate or Evil Twin access points. So that way, whenever someone connects, they will see that cert that you made. So you can see that there is at the bottom here a type feature. So GTC and MSChap. So MSChap is the ability to derive the MSChap hash, which can be domain credentials. But as Stephen was mentioning before, GTC is the act of downgrading. Ironically, GTC, which obviously would always be an attacker's end goal because it's clear text credentials, you don't have to crack or try to brute force them, doesn't actually work against Windows devices. It's the only one it doesn't work against. Android, iOS, OS X, they're all vulnerable, but not Windows. So you can see right here, here's a sample of it using MSChap and the hashes. And that they're stored in the table. So you can take these and start performing brute force attacks against it to derive the clear text credentials. Right now we're just going to show you a demo of what it would look like if it was GTC. So like I mentioned before, this would only be working against Android or iOS devices. So it follows the same type of setup. And you'll see on the side here, there's an example of a Windows, how it would look. They automatically connect. Clear text credits. So now you can log in as that user.
Right, and these are domain credentials. This isn't just going to get me on the wireless network. If I want to hop on your OWA and read your email, I can do that too, right? If you have a single-factor VPN, I could go in through the internet, right? If you have multiple business locations that are broadcasting the same SSIDs, I could go to another location or call up a homie that's on the other side of the country and be like, hey, I have credentials, you could log into this place over here, right?
And this is what that cert would look like. So this is the cert that we used in that previous demo. You can see it meets all the requirements of all the information anyone would see. So if it was proper client and everything like that, it'd be hard for a user to discern that between a fake one. So this is our last demo. This illustrates the captive portal attack. So with this one, a lot of default splash pages are available, like Cisco's. In this case, we'll be demoing actually Cisco's. And this is a very interesting attack because not only do you have companies now that are thinking that, okay, well, my guest portal doesn't really matter. I'll get people to log in. I don't want their phones on our network. So I will give them domain credentials. That way, it's set up so that way it's using domain credentials, but it'll be segmented off. All they have to do is they have to log in if they want to bring their devices. We see this a lot with BYOD. We also see this as a way for people who have, vendors or guests coming into a building or an office to work temporarily, or contractors. They'll assign them credentials, maybe that they're not connected directly to domain, but maybe have domain-like queries or on a subdomain. But it still gives them access to an internal wireless network. And just by setting up this captive portal, it's hard for them to determine. Like if you camp out in the lobby as people are coming in, they might get kicked off and redirected to your malicious portal. So that's why setting up the things like setting on the right channel and all these things are really important. And that's where it plays into reviewing all that information before you launch the attack. So it spins up it uses HostAPD and Apache, as well as a lot of Python libraries to modify DNS and a lot of routing records. So here on the right, you'll see how it would look from a phone's perspective. You see the network, okay? And just by clicking on it, it automatically will redirect you. So there's no they have to load up a page. It just sends them right there.
This is what I was mentioning about like doing an internal audit with your own company. If you wanted to stand one of these up and see if your employees would actually fall for this would be a good test to utilize.
And then it just sends them right back. It says they're connected, and you can see credentials and everything like that. So there are several more modules, and we're just going to talk about them, but a lot of these were just ones that we developed and are specifically releasing here at GrrCon. The newest version is out, version 3. This is GrrCon release. So things to help elevate, your ability to be effective, being able to spoof and change your MAC address of the access point you're running, doing passive and active pre-shared handshake captures. There's been a lot of information recently around cracking and gathering handshakes for pre-shared keys. So a lot of these modules that we've built incorporate a lot of those new techniques. Probe packets. So these are ones that would look to see about trying to figure out which networks are hidden by doing active attacks. So sending deauth packets actively versus passively. As well as some background functionality for sniffing. So if you can send the sniffing agent to the background to do other things, maybe sending deauth packets or spinning up a legitimate access point to kind of see maybe log the communication. And finally,
yeah. So, how many people are familiar with the Wardriving? Right. All right. For those unfamiliar, what you do is you take a wireless antenna and a GPS antenna. You drive around, walk around, whatever, and every time you capture a beacon frame, you notice a network, it's recorded with a GPS latitude and longitude. So then you have a database of where all these wireless networks are. So it's like you can drive around your own neighborhood and you can drive your neighbors and you can see, what the access points are in your neighborhood, right? And that's cool and all, but wouldn't it be cool if you had like a bigger database that you could access? So there's this website called Wiggle. Wiggle is an open source Wardriving database that numerous people upload to. Are there any Wigglers in here? No? Yeah, we got
a few.
Yeah, so there's like a ranking system and things like that you can upload. And all the information is publicly accessible. So we've actually added in queries to the Wiggle API. So you can actually call and we're going to show you some cool stuff here. But really simple. You go to Wiggle. It's a free account. If you don't upload, if you don't contribute, you get like 10 queries a day, I believe is what it is. But once you start uploading stuff, your queries, I think it goes up to like 100 a day. And you can always email them and ask them if you wanted to do more. You get an API name and a token to put in there, and it's that easy. So with this, I'm just using the SSID ATT Wi-Fi, right? One of the most common ones you'll see around here. So we can go to the next slide here.
Just something to add. So a lot of this information is free and public. So I think one of the first questions I've ever heard about when I heard about Wiggle that people kind of posed to me is, isn't there some kind of ethical issue around this? But the problem is that it's kind of hard to consider this private or, a breach of information because these packets are constantly being sent out and they're out in public space, as well as a lot of this information is not encrypted based on the actual 802.11 standard. So there are some issues around that, but overall, a lot of the ethical debates and reviews of policies and from a legal point of view, this information is, can be collected freely. And that's kind of where, as an attacker, we can really abuse that.
Yeah, all right. So on the left here, this is what happened after putting in ATT Wi-Fi. Now, this map should be a lot bigger, as well as the Xfinity one as well. But the reason that it's limited in what you see is because the results are kind of limited to the first 100 results. So that's why we see that. Like Xfinity Wi-Fi, we all know that should have covered the whole country, right? There is that. So think about that, though. So you can physically locate devices through open source intelligence, not ever having to go on site, right? Think about what we mentioned earlier about probe requests. How your probes are, calling out to Bob's Wi-Fi. What do you think is going to happen if I put in Bob's Wi-Fi and look at that? How many people have a Bob's Wi-Fi at home? Yeah, exactly. So let's go to the next one.
So who here knows that GrrCon has a Wi-Fi running for the convention? Anyone?
Yeah, exactly. So if you query Wiggle for GrrCon, look at the only result that comes up. Right there in Grand Rapids. So that's interesting on a level So where if I'm capturing packets in this room and I'm capturing everyone's probe requests, and I start putting in, Jack's home Wi-Fi, I'm going to get some results. It's not going to be very many, right? Think about your wireless network name at home. It's probably unique to you, right? It's like tattoos. Everyone has their own funny one, right? So with this opens up a whole new thing. You can literally track people to their house. If you're collecting packets at work, and you go and you start throwing in every probe request that you see into this map, you'll be able to find people's houses because this is just open source data that people are just always sending this, uploading this to the internet.
And one other thing is you might be able to, you target one building, say in New York, and you've gathered all this information, but maybe you can't get in. Maybe you just can't get close enough. Maybe there's like a guard station, something like that. You could punch this information and find another building where they're broadcasting the same network name and all that stuff. Maybe it has weaker security. Maybe this is like, there's nothing. It's just a free parking lot right beside it where you can just drive up and connect.
What we're talking about with gathering, legitimate domain credentials. Say I'm in Colorado. I'm from Denver, Colorado. Say I get some credentials in Colorado, but I don't want to log in there. I don't want to burn my location, right? I could query the SSID, see where it's located throughout the country, and, have somebody else do that for me, right? So this is just an SSID. This is looking for a network name in itself. On the next slide, what I'm doing is querying a specific MAC address. Now this is a MAC address of a Wi-Fi hotspot that I carry on me. And I don't have it turned on when I'm ward driving for Wiggle. So this is stuff that other people have collected on me, right? You can see I'm from Denver, so there's a few slots there in Colorado. You can see I've been to Texas a little bit. You can see I've been to Kansas City and over in Oregon as well. So that's literally tracking my location solely from a MAC address of a hotspot, right? So you're, think about people's cars. A lot of new cars nowadays broadcast their own Wi-Fi, and they're typically not unique, right? It'll be like John's Explorer, right? However, if you get the specific MAC address, you can track that specific car. Instead of every John's Explorer out there, you're tracking, John Smith's Explorer.
So to recap,
yeah.
SniffAir is an open source wireless framework for security, assessing, and attacking of wireless networks. It's designed with red teams and blue teams in mind. Allows you to perform complex and powerful queries to analyze the data to kind of get the accurate information in real time, as well as performing real-world scenario attacks against wireless networks and clients. So we're always adding and adding to this. This tool was initially was created 2 years ago, and we've been working on it. So we're still developing more vulnerability assessing modules, more attacks as we come up with them, post-decks, and reporting modules and metrics, as well as we're looking to adapt into Bluetooth attacks and Bluetooth scanning and profiling. So you can see here's the GitHub link for SniffAir if you want to take a look at it, play around with it. Our Twitter handles if you ever have any questions or anything like that. But right now, thank you guys. And are there any questions? Pardon? So the question was, do you have to modify your Wi-Fi card? All you have to do, and SniffAir does it itself, is it puts it in monitor mode when you need to do something, say a sniffing or an active attack, and then restores it to its original state that you had it in once you've done that attack or module.
Right. We wanted to make this very user-friendly. A lot of people talk shit about Metasploit, saying it's a script kiddie tool. But hey, I popped my first shell with Metasploit, right? And it teaches you the basics. A lot of people talk shit about a Wi-Fi pineapple. I started with a Wi-Fi pineapple. And it helped me learn the basics of how Wi-Fi worked. That's why we wanted to make a tool that anyone could use and help people learn Wi-Fi. If you're unfamiliar with it, just get in the tool, start messing around. Go to the GitHub, look at the wiki, look at some of the documentation. We want to help people learn about this.
You can get an alpha card or even like the TP-Link cards, the USB ones, for $20 on Amazon and just play around with this. Yes? So the question was about WPA2 crack and WPA3. So we are looking at WPA3, but something that I always like to remind people is that the vendors just now are starting to develop devices for WPA3, and that will be rolling out in the next year. That doesn't mean companies are going to be jumping on it, because that's really expensive to replace your whole wireless infrastructure with new compatible devices, as well as then your clients have to be compatible. So that means new laptops, new phones and stuff. So we are actively researching it, but the real world application we'll start to see more and more, and probably in 2020, 2021, 2022. as for crack, crack's one of those interesting ones. So we have the ability to kind of validate. Right now in the open source community, you can validate that vulnerability, but at the same point, it's kind of hard to actually accurately
exploit it.
Yes,
right? Yeah.
because of the fact that not only do you need to basically be manning the middle, there are very few publicly known ways to do many of those listed vulnerabilities. The only one is the client channel attack, where you force them to join your access point on a different channel. You basically are saying, hey, we're moving to a new channel, and then get them to actively connect. But the problem with that is that you have to be able to man the middle traffic of both a vulnerable AP and client for it to have high success.
But yeah, we're really active in the security community, so we're all crack. The dudes at Hashcat came out with the PMKID kind of attack as well. The dudes that made Mana released a bunch of new man-in-the-middle attacks at DEF CON. We're always going to be implementing new attack modules as people put them out. We want this to be the wireless Metasploit. We want this to be the one tool to rule them all, right? Yeah.
Any other questions? Yes.
Yes. 5
So the
gigahertz
question is, does it work with 5 gigahertz? Yes, it does both 2.4 and 5.
Did you have a question?
So the question was, how long does it take typically we've experienced to crack a pre-shared key using like Hashcat or something with GPUs?
Yeah, so the GPU cracker that we have at work, it's 6 1080 Ti's, right? It's a beast of a machine. Typically a wireless engagement for us is 2 to 3 days, right? So I'm not going to let it run for a week. With that type of hardware, we'll let it run for a few hours, and if it doesn't, we'll change the text. So if we're just using wordless, we'll swap to a mask or something like that, or try something more targeted in nature. But we never let it run for, days, weeks, right? Because I'm not going to be on site once that password is cracked, right?
And just that, it also comes down to really knowing Hashcat really well, learning about the different ways of generating word lists, computations, rules, as well as even implementing maybe Markov chains as well. By doing simple things instead of just throwing in a word list, by actually kind of adjusting it, kind of creating your own, modifying it based on what you've seen when you're there, we've had increased success rate and reduced times cracking them. Any other questions? Okay.
Thank you.
Thank you, everyone.